Imagine living a life filled with happiness and pain, love and grief, ambition and despair. A life with parents, kids, grandkids, and ultimately, the death of everyone, including yourself. And then it all happens again in the same way. You make the same choices, the same people die in the same way, and your reaction is the same. I'm describing the existentialist philosopher Friedrich Nietzsche's concept of eternal recurrence. It's a hypothetical notion he put forward as an exercise in overcoming yourself to affirm all of life. In order to become who you are and realize your full potential, you need to confront the limiting aspects of your character. Eternal recurrence was meant to be an excruciating thought, but many people have interpreted it as the opposite. Some of us find the idea of re-experiencing our lives to be exciting. We cling to our experiences and our consciousness. We hate the idea of letting our lives go or losing our cherished memories. Similarly, the idea of rebirth in Hinduism and Buddhism get people excited. We want our consciousness to live on, even if it's in another body. In both of these religions, the idea of rebirth isn't supposed to be positive. You're supposed to work towards ending the cycle of rebirth by embracing the principles and practices of Hindu and Buddhist thought. Until recently, this notion of rebirth had some cosmological relevance in the theory known as the Big Crunch. The idea is that the expanding cosmos will eventually collapse back into itself and reform into a singularity that could spark another Big Bang. In this process, instead of the universe expanding forever, it would reach a point where its size would start to decrease. This would eventually cause gravity to become the dominant force. The universe would shrink and eventually collapse onto itself, and the cycle would continue over and over again, a cyclical rebirth of the universe. It's an idea that sparks hope that life could begin again. We wouldn't be left with a cold, empty universe. And maybe our consciousness would be reborn again somehow in this process, just like in Nietzsche's hypothetical concept. Trillions of years from now, we will live on. Sadly, this theory of the universe isn't the most likely according to modern physics. In the late 1990s, astronomers studied 42 supernovae. These are white dwarf stars that siphon gas from a companion star. The increase in mass causes a runaway nuclear reaction that ultimately leads to a very bright explosion, a supernova. After studying these supernovae, they discovered something that would change how we understand the universe. Distant supernovae were dimmer than they expected. Why does this matter? Well, if the expansion of the universe was slowing down, as we formerly expected, then the supernovae would be brighter. But the fact that they were dimmer meant that the universe's expansion is actually speeding up. This speeding up went against our understanding of gravity in the universe, so either Einstein's theory of gravity is wrong, or there's something else at play. Some new components in the universe that we hadn't accounted for. That something is a force called dark energy. Dark energy is believed to be virtual matter that pops in and out of existence. It doesn't interfere with energy conservation, and instead of pulling like gravity, it pushes. According to astronomers, the universe is made up of 69% dark energy and 26% dark matter, both of which are invisible. Everything we can see, like the stars, planets, all the trees, places, and people that have ever existed, only make up 4.9% of the universe. The remaining 0.1% are neutrinos, and 0.01% are photons. The force of dark energy is believed to be a constant, expanding the universe continuously without stopping or regressing. The impact of this dark energy is that the expansion of the universe will never slow down. Eventually, the universe will expand so much that no distant galaxy will be visible from our own Milky Way. And by then, our galaxy would have merged with the neighboring galaxies. The end result here is what's known as the Big Freeze, or the heat death of the universe. Due to the endless expansion, all heat will be distributed evenly across the universe, leaving the cosmos in a final resting state at just above absolute zero. Understanding the science behind how our universe works can be really challenging, but with Brilliant.org, the sponsor of today's video, it doesn't have to be. Whether it's physics, math, or computer science, Brilliant offers thousands of lessons that are broken down into bite-sized pieces and are taught interactively. That way you're not lost in all the theory of these mechanisms, but can actually understand how they work in the real world. AI has practically taken over the world, but most of us still don't understand what exactly it is or how it works. If you want to learn how things like ChatGPT work, Brilliant's course on how large language models work is the best place to start. With features that allow you to challenge yourself and compete with others, Brilliant makes learning even the most complex subjects fun. Each course is customized to fit your skill level and goal. So just set where you are now and where you want to be, and Brilliant will do the rest. To try out the How Large Language Models Work course and all the other courses completely free for 30 days, go to brilliant.org/aperture or click the link in the description. The first 200 people to visit also get 20% off a premium subscription, which unlocks every single course Brilliant has to offer. Back to our story. Entropy is the measurement of everything in the universe moving from order to disorder. According to a thermodynamic principle, entropy will increase until it reaches its maximum value, and when entropy has reached this value, all the heat in the universe would have been evenly distributed. There will be no more room for usable heat energy, and once there's no heat, there is nothing. Star formation will have ended long before this. The universe would be so vast that its gas supplies would be spread too thin for any new stars to be born. Galaxies will be gone and all matter will be locked inside black holes. Eventually, even the black holes will disappear. This dark era will last way longer than any other period of the universe. Time will be almost infinite at this point. Time began with the Big Bang, and it likely ends with the Big Freeze. Mechanical motion in the universe will cease altogether. Nothing will ever happen again. The universe will effectively be dead. But is this heat death a sure thing? Just like everything else, not exactly. The assumption the Big Freeze makes is that the force of dark energy is a constant, but according to our best measurements, there's a bit of uncertainty about whether dark energy is a constant. It's also possible that the force of dark energy will just eventually change. Dark energy could become stronger, and even if it gets just a bit stronger, it could lead to another theory of the universe's end, the Big Rip. This is where the pull of the universe's expansion becomes stronger than the gravity it contains. This would effectively tear the visible universes apart, including galaxies, stars, black holes, and planets. The universe would be left with disconnected particles, somewhat reminiscent of the way heat energy is evenly distributed in the Big Freeze. Dark energy could also become weaker. Gravity would then win its struggle with the dark energy, and the universe would collapse, and this becomes the Big Crunch scenario again. If you were to make a bet right now about how the universe might end, the smart money would be on the Big Freeze. It's most likely, given what astronomers have observed, that dark energy will remain a constant. Thinking of the universe ending can induce a feeling of panic. We have a hard time imagining our world ending or even our lives. The default way of life is to fight against death. When someone dies in the hospital, we assume that everything possible was done to prevent death and are outraged if that wasn't the case. Horror films reaffirm the underlying assumption that death is to be feared. Death is so terrible to so many of us that the genre is called horror. We can't imagine anything worse than death. To cope with death, we imagine a future where our bodies are no longer the end of our consciousness. Futurists talk about a time when our minds will simply be uploaded to a simulation. But as much as we want to fight it, death is inevitable, and as best as we can determine from our current understanding of the universe, it all comes to an end. Motion ends, and if time still exists, it'll have no relevance. Is it possible to accept the inevitable without imagining an afterlife or any kind of escape from nothingness? The Greek philosopher Epicurus had an angle that might help. He asks you to imagine what it's like being dead, but you can't actually imagine being dead. Death is an absence of existence. There is no perspective from a view of nothingness. Death isn't an experience, it's nothing to us. You won't feel the pain of absence or nothingness because that would require a perspective. Pain is rightfully feared because it is an experience, but death is no experience. Fearing it is pointless. Why should I fear death? If I am, death is not. If death is, I am not. Further reinforcing this idea is the Roman poet Lucretius. In the 1st century BCE, he insisted that your pre-existence is the same as death. And just like death, we can't imagine what it's like to not exist before we were born. We don't fear our pre-existence just as we shouldn't fear our post-existence. I do not expect that intellectualizing away the fear of death will be entirely effective in getting rid of it, but it can potentially calm the mind somewhat when the fear of death overwhelms too often. In truth, we don't want to be completely fearless of our morality anyway. That would probably be a reckless life that leads to needless harm to yourself and potentially others. And it doesn't address the fear of losing others. This is a painful experience regardless of your perspective. Life is inevitably painful, and one day, the universe will be devoid of it. you, me, and almost everything we know. Unless, of course, despite our most likely predictions, the cycle continues. But I'm afraid that might be wishful thinking or require a leap of faith. If you're struggling with the fear of death or you're grieving the loss of a loved one, I suggest you watch this video. It's helped thousands of people, and I hope it'll help you too.